Alright, this is part 2 of your Unit 8 review, so we're picking up where we left off in part 1. So we're starting with question 11 here. So question 11 says we need to write the piecewise function that corresponds to this graph. So I've gone ahead and set this up. We always have our f of x with a bracket here, and we write the function part on the left side and we write the domain on the right side. So I usually work left to right, so we need to write the function that describes this piece. Notice we have 3 pieces, so we're going to have 3 functions and 3 domains for those functions. Alright, so this is y equals -2. It's just a horizontal line segment. Y equals -2 describes it. And it is good for a domain of greater than -infinity, but less than -1, 2, 3. Alright. This next piece is a parabola. It's not stretched, it's not moved left and right or up and down, so it's just x squared describes it. And now the domain, notice how this one left off at -3, so this one is likely going to pick up at -3, which it does. And we're filled in because we have a filled in dot there, so we're equal to here. And then that goes to a domain of 2, so an x value of 2 right here, but we have an open circle, so we're not equal to here. Alright, and then, so that's the first 2 pieces. Now we're going to write this piece. So that's a line, and it has a slope of 1 because it's going up 1 over 1, up 1 over 1. So that's just y equals x, and then we have to identify the y-intercept. That's the second part of the line. You've got to identify the slope and the y-intercept. So the y-intercept, if we track this down, if we extended this line segment down, it would be right here at -1, 2, 3, 4. Alright, so that would be x minus 4 would describe this line segment, and that is good for a domain of x greater than or equal to 2. Okay, I could have written it x is greater than or equal to 2 and less than infinity, but it's okay to write it just like I did right here. It means the same thing. Alright, so that's it for question 11. Now let's move on to 12. Alright, problem 12. We are going to be applying our piecewise functions here. So problem 12 says a policeman walking a beat leaves headquarters and walks 8 blocks in 15 minutes. So we already know we're talking about blocks as a distance and minutes as a time. So time and distance are the 2 things we're talking about. And then we can just read through the story and create the graph. I think it's always easier to start with a table. So on our x-axis we're going to be talking about time, and on our f of t axis we're talking about blocks in distance, a distance in blocks. So we're just going to create a table. So obviously it's going to start at 0, 0, time of 0 and 0 distance, and now let's just piece this together. So first he leaves headquarters and walks 8 blocks in 15 minutes, so our time is going to be 15 minutes, and the distance is, as a function of time here, is 8 blocks. So then he stays for 30 minutes. So his distance, the f of t value, the y value is not changing, so that's still going to be 8, and the time has increased by 30 minutes, so we need to add 30 to this 15, so that would put him at a total time of 45 minutes. He then continues on his way, a distance of 4 blocks in 10 minutes, so our time, our x-axis here, our x is going to increase by 10, so that takes us to 55 there for time, and then he went 4 more blocks, so his total distance now is 12 blocks. It says he realizes he left his wallet at the donut shop, so walking briskly he returns to the shop in 5 minutes, so time is going up by 5 minutes, but he went back to the donut shop, so he's going to be back at 8 total blocks. So he's going back the 4 blocks away. Okay, so his y value here is actually going to decrease, but his x value did increase there. Alright, so I'm going to underline that for what we just did. And a robbery call comes in, so he goes 8 more blocks. So that's going to take him to 16 blocks. And he arrives at the scene of the crime in only 6 minutes, so that takes us to 66 minutes. And that's going to be it right there. That's going to be the every part of the problem. So now we can actually graph this. So we're going to have our y-axis there and our x-axis here. So our x-axis, we're using t for time. So that's t, and that's in minutes. And our f of t axis here, our y-axis, and that was in blocks. Alright, so we had the 0, 0 point here. Then we would, let's go ahead and scale our axis here. So let's just make it 10 at a time. So that's 10, 20, 30, 40, 50, 60, and the max is out here at 66. So I'm going to put that right there. And then let's bring our time up. The maximum, or pardon me, our y-axis here, blocks, the maximum there is 16. So let's do maybe 5 at a time. So 5, 10, and 15 would be here. So we'll be just above that. All right, so now let's start plotting these points. So we started at 0, 0 there. 15, 8 would be about right here. So 15, 8. The next point is 45, 8. So it's just straight across here. 45, 8. Alright, and then it's 55, 12. So call that 55, 12 there. 55, 12. Making this table makes this a lot easier to set it up. And then 60 back down to 8. So right there, 60, 8. And then lastly we have 66, 16. So right up here, 66, 16. Alright, and then we just need to complete our graph by connecting these points. Try to make this look as good as possible here. So horizontal line segment there, here, here, and there. Alright, so that's all they asked us to do on this one, is actually graph it. So we're going to be using this over the next several problems. So let's go on to question 13 now. Alright, so problem 13 says, over what interval of time is his speed 0? Remember, our slope here, we've got line segments here. So the slope is speed in this case because it's distance over time. It's the change in the y-axis over the change in the x-axis, so that's distance over time, which would be speed. In this case, it would be measured in blocks per minute. So over what interval of time is his speed 0? Well, that's when he is not moving. So that would be from time 15 to time 45 right here. So to write that interval, we can just say 15 to 45. 14, over what interval of time is his speed negative? Well, remember the slope describes his speed in this case. So the slope is negative only in this section right there. So that would be from time 55 to time 60. Alright, easy enough. Now let's move on to the next couple of problems. Alright, so problem 15 here says, what is the rate of change of his position at 62 minutes? Remember, rate of change is the slope. In this case, in this problem situation, the rate of change is describing speed. So at 62 minutes is approximately right here. So we're on this line segment, so it would be the slope. The rate of change, remember, is slope, so the slope of this line segment. And slope, remember, is y2 minus y1 over x2 minus x1. We could also put these points in our calculator and stat edit and get it, but these numbers are fairly simple, so we can just do that. So the change in y is going to be 16 minus 8, so that's just 8, over the change in x would be 66 minus 60, so that's just 6, so it's 8 over 6, which equals 4/3. So 4 over 3. We could also write that as a decimal, but that would be more complicated than just leaving it as 4/3. And then we need to put our units on here, so that'd be blocks per minute. So 4/3 would be the answer there. All right, 16. What is the rate of change at 55 minutes? Okay, well, 55 minutes, remember, we're right here at this corner point, this cusp, where we are changing. The rate of change is actually changing because that's an endpoint. It's this line segment is ending and this one is beginning. So in these problem situations, we had to say that that was actually undefined. We can't tell what the slope is exactly right there because it is changing. You could draw an infinite number of sloped line segments right there at that point. So we have to say that it's undefined or undetermined. All right, let's move on to question 17, and then we'll call part 2 done and finish up the remainder of the review in part 3. All right, so question 17 says write a piecewise function that describes the policeman's travels. So we have 1, 2, 3, 4, 5 total pieces there. So we're going to have to write 5 different functions. So we're going to write P of t here, and we're going to put all the functions here, and then we'll put the domains here for each one of these segments. So to make this relatively quick, we're going to use stat edit in our calculator. So stat and then edit, and we're just going to put these points in here. So we've got to put each endpoint, so the end point and the beginning point. So we're going to put that point and that point to get this line segment right here. So that would be 0 and 15 for my x coordinates. Those go in list 1, and 0 and 8 for my y coordinates. We could also do this algebraically, but I'm fine if you use your calculator, and it's a lot faster. I just want you to know how to apply this. So stat, calc, option 4, and then just enter all the way through, and it gives us a y-intercept of 0 and then 0.53 repeating. So I'm going to convert that to a fraction to make it easier. So 0.5 and a bunch of 3's here. Math, enter, 8/15. Okay, that works. So this segment is described as just 8/15 x. Remember that 8/15 was our slope, 0.53 with the 3 repeating converts to 8/15. So 8/15 x, and the y-intercept is 0. So that's all we need. And then that domain, I'm going to do this in another color so we don't get confused. And that was good for, and I need to, let's fix that and make that t, not x. We are using t here. Alright, so that was good for domain from 0 to 15. And I don't care if you put greater than or equal to or just the less than sign here. You could put the equal to's. It really doesn't matter. Either way works. So that was from 0 to 15. Alright. And then let's find this next section. This one's pretty easy because it's a horizontal line segment, and so those are y equals the y coordinate of the horizontal line segment. So that's just y equals 8 in this case. So that's y equals 8 would be the second piece, and that's good for a domain of t is less than 45 and greater than 15. So that went from 15 right here to 45. Alright, the next section has these 2 points in them. These numbers are pretty simple, so we could put them in the calculator, but they're pretty easy to work with. So it would be the change in y, so 12 minus 8. I'll write it over here to the side and then we'll erase it in a minute. So 12 minus 8 over 55 minus 45. Okay, so that is 4 over 10, which reduces to 2/5. Okay, so 2/5 t will work. And then we just need to identify the y-intercept, which is going to be the hardest part. So let's go ahead and put that in our calculator. Slope is easy. The y-intercept would be more of a pain. So we're going to put these 2 points in there. 45, 55 for my x's. Change that to 45. 45, there we go, finally got it. And 8 and 12 for the y coordinates. Then stat, calc, option 4, enter, 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 enter. And that's 0.4, which is the same thing as 2/5, and then the y-intercept was what we needed, and that's minus 10. Okay, I was doing those in other colors, but I messed that up. So 40, that was good for a domain of 45 to 55, so less than 55, greater than 45 here. All right, now this line segment, let's just put the points in here. We could find the slope pretty easy, but the y-intercept is the problem here. That's going to be a pretty, notice this is negatively sloped, so it's going to be way up here. And we could find it algebraically, but that takes too long. So we're going to put in 55 and 60 for our x coordinates. 55 and 60. We're just using these 2 points from our table. 55 and 60 for the x, and that would be 12 and 8 for the y. All right. So stat calc option 4, enter, and that's negative 0.8. All right, so negative 0.8, or we could use 4/5. Either way, I'm just going to use 0.8. Negative 0.8 t plus 56. Plus 56. So that describes the equation part of it. Now we need the domain, so that's less than 60, greater than 55. All right, and we're down to the last piece here. So let's put those points in quickly and we'll be done with this part. Alright, so our x coordinates would be 60 and 66, so it's these 2 points right here in our table. So 60, 66, and 8 and 16 for our y's. 8 and 16. Okay, stat calc 4, enter several times here, and that's 1 1/3, which is 4/3. I think it'll be easier to write it that way. So it's 4/3 t minus 72. So 4/3 t minus 72, and that domain is from a minimum value of 60, and the max would be 66. All right, so that is it. Let's just check these. 4/3 t minus 72, negative 0.8 or negative 4/5 t, either way, same thing, plus 56 for the y-intercept. 2/5 t minus 10, 8, and 8/15 t. And this was good for a domain of 0 to 15 right here. This one was 15 to 45. Then this third piece was from 45 to 55. The fourth piece is from 55 to 60. and the last piece is from 60 to 66. So that describes all of it. All right, so let's end part 2 here, and we'll wrap this up in part 3. See you in the next video.